One of my volunteer activities is that I'm a STEM ambassador. There are various different activities I've done as a STEM ambassador. One example is attending school careers fairs to show the different opportunities for a career in STEM. Here's a quick explanation of one of the activities I've done at a recent careers fair. It's mainly about some programming I did, creating a touch-controlled generator and UPS simulator. This was created using a Raspberry Pi and Pygame Zero. This video will explain some of the benefits of the object-oriented programming that I used, but I'm also going to briefly show some 3D models that I made, which show the same type of thing, but using a model that the pupils could handle. The STEM activity is based around my role as a data center manager, and is specifically about the engineering infrastructure that we use to ensure that there is power to keep the computers running 24 hours a day. During the careers fair, I mainly talk about how we use UPS and generators to keep the data center running through a mains power failure. I have two demonstrations, one of which is based around a physical 3D model, showing some of the main components, and the other is a simulation using a Raspberry Pi and touchscreen to demonstrate how generators auto-start and the way that UPS supports the technical load whilst waiting for the generators to start. I'm going to explain my 3D printed models first, so if you're more interested about the simulation I created on the Raspberry Pi, then you can skip to the next chapter, or just keep watching, as this chapter is only quite short. I tend to use the 3D models more, as they're more visual and better when there's a large group of students, but the simulator has advantages in terms of being able to show how the power is being supplied. Note that these are not to scale, either in terms of physical shape and size, or in the charge and discharge times. Also on the simulator, I use green to indicate something is energized and red to indicate when it's not. This is the opposite of what many control panels would show. They often use red to indicate a panel is live and hence is dangerous. Models are designed in TinkerCAD using basic shapes and then 3D printed. I included some simple electronics, including switches, LEDs and some diodes, to show how we can keep power to the server. I also use a one-line diagram, or sometimes known as a single line diagram, to show how these are connected using a simplified design. This works well, as I also use 3.5mm jacks and cables to represent the cables, so a single cable in the model is represented by a single line on the diagram. Here's the simulator. It's running on a Raspberry Pi, which is connected to a Raspberry Pi touchscreen. This looks similar to a touchscreen you may encounter on a hardware device. It shows the typical state of the generators. There is power coming in from the mains electricity supply through this transformer symbol. The generator is shown here and is in auto mode, ready to start when required. I can turn the power off from the mains by clicking on the button here. This will essentially simulate a power failure. In real life, switches for this are much bigger, switching 11,000 volts with built-in anti-arcing mechanisms. When I turn this off, then you'll see the generator start automatically. It will go to amber, then sync up with the generators and then turn to green to provide power to the UPS. You'll also see that the charge of the UPS depleted initially, and then it started to charge back up when the power is provided by the generator. This is all done automatically, ensuring that this is seamless to the end user. When the power is restored from the electrical grid, then the switch back to the main supply is normally done manually to ensure that the main supply is stable first. And then it's restored to auto mode, so that it will automatically start when required. The program is written in Pygame Zero. It's mainly centered around the actor class, which is used for images or sprites, and also makes use of lines, although they are not implemented as classes in Pygame Zero. This shows a simplified UML class diagram. I've just focused on some of the classes that handle the main objects. The wire class is a simple class used to represent the wires, or rather the lines in the one-line diagram. It uses Pygame Zero lines, but creates these as a wire object, so that I can change their status and hence the colour of the wires when they are energized or not. The more interesting classes are those related to the actor class. The actor class is provided by Pygame Zero, represents images that are displayed on the screen. In this case, these are images that reflect the different symbols and the menus. Rather than use them directly as actors, I've subclassed these. The class shown on the right is a menu item class, which is used for the buttons that can be pressed. One thing about using a game development framework instead of a standard GUI framework is that it doesn't have buttons, and so you have to implement them yourself. So this uses images with different coloured rectangles to represent the switches and their different states. You can see that it has some methods for setting the status and updating the menu. You'll also notice there's a draw method. The draw method overrides the actors draw method. It does call the actors draw method as well, but it also adds some text to the screen. The diag symbol class performs a similar job to the menu item, but for the diagram circuit symbols instead. This class is used directly by the transformer symbol. The generator and UPS symbols have their own subclasses of the diag symbol class, which adds additional functionality. In the case of the generator, handling the generator starting and running status, and for the UPS it handles the updating of the battery charge level display. There is also a bus class, but that is similar to the wire, and so I've not shown it here to keep the diagram simple. The main code is then in simulator.py, which controls the interaction with the user and updates the appropriate instances. Most of the code is in creating the diagram menus by creating lists of all the different objects. There are some functions which look at the status of the various objects, such as the generator and the transformer, and then updates the related objects. To run, it's just a case of calling pgzrun with simulator.py, and then it runs the application. The useful thing about this is the way you can subclass parent classes, with the advantage that you can reuse most of the existing code and just add the additional frames for each of the subclasses. You can find more detail by looking at the source code. Look for the link in the description. Hope you found that interesting. I'll be adding more videos in the future based around the Raspberry Pi, and I also hope to add some more about the new Raspberry Pi Pico wireless in the next week or so. So please subscribe and click the notification icon if you haven't already. Thanks for watching, and I look forward to seeing you in a future video.